Another method of sanitizing the water is through ultraviolet sanitation. I don't know how familiar you are with this, but ultraviolet light will kill any pathogens. We like these because they're very low maintenance. These bulbs last 10,000 hours, so you don't have to worry about changing anything regularly. There's nothing to add during the year, so they're great from that perspective. The only downside of UV sanitation or sterilization is that once that water has left that chamber and it's sanitized, it can be recontaminated downstream. There's no residual killing value. So if it's going to toilet tanks, for example, if it's going into another storage area, there is the chance that water can be recontaminated again. And so particularly when we're going to water inside the building, most municipalities would prefer to see chlorine because they can measure it, they know it's there, they're familiar with it. If we're going to be irrigating and the water's going to go from our system right out to the irrigation system, then we almost always use ultraviolet. But we do, in almost every system, have one or the other.
Why would there be a difference in contamination versus just city water? I mean, going to a different area.
You mean as far as irrigation versus?
Why would, no, you're saying have to use the ultraviolet.
Right.
Well, what's something that's coming in from city water?
City water has residual chlorine in it. If you measure the chlorine in your city water, you'll find there's half a part per million in there, which is providing that residual killing safety factor downstream. That's why municipalities use chlorine, because from that point where it's being charged with chlorine down to the point of use, you've got some amount of chlorine along the way that's keeping bacteria and algae from growing in it. No, in this case we're saying that, yeah, you're right, yes. So if there was some, let's say you're coming off a rooftop, you've got bacteria in that water, you've got perhaps viruses that are in there, just other contaminants that might be irritants, so that we're thinking of that as a way for spray irrigation. Then you wouldn't need to. Yeah, and then the few systems we do that don't have any kind of sanitation are those where we're going subsurface. And then local codes don't require it, and we don't add that extra step. The final filtration is a step where we're going to polish the water. We're going to take it down maybe 200 microns in that initial stage down to a very clean water state. There are a number of ways to do that. Bag filters are the most, bag filters would be the least expensive way to do that, but they require maintenance. You got to change those regularly. We started using a lot of these self-cleaning filters now. So this is, Amiad makes these, and they actually are able to clean the water and then backwash themselves, and so you don't have any kind of maintenance with them at all, and that happens automatically. This is a greywater. We use this for greywater. It's ultrafiltration that was talked about yesterday in one of the topics, and ultrafiltration gets the water very clean. So if we're taking a relatively contaminated water like greywater, we don't know what kind of contaminants are in there. It could be anything from hair to to bacteria to viruses. Then we want to have a more aggressive filtration step. And ultrafiltration does that for us. It takes the water down to 0.02 microns in size. So that's actually filtering out bacteria, viruses at that kind of level and getting the water very, very clean, so that if we're going to flush toilets or irrigate with that water, the water quality is very, very high. So it really depends, once again, on what is the source of water, what is the use of water, how clean does it need to be for the intended use. And we're mixing and matching these components in order to best make the system work for that particular building in the best way that it can. I was talking about the filtration methodology. This is just, and I know you can't see this, but it is in the slides, just showing you that you start on the left-hand side here with just with standard kind of filters. You move over here all the way to the right. I got that right. Yes, other way around. So this is just a standard filtration on this side. Ultrafiltration is kind of one step before reverse osmosis. So it's less expensive, it's more efficient than reverse osmosis, and does a darn good job, but it won't take out dissolved solids, won't remove salts and kind of things. But for water reuse, it doesn't really make any difference anyway. Some of the ultrafiltration membranes that we use.
5 minutes remaining for session 3. 5 minutes.
The last step is to get the water pressurized, and this is where we want to match the pressure coming out of the system, what the requirements are. It could be a very simple, this is a little flow jet pump here for maybe a simple irrigation step we're doing, up to a large skid like this that's going to be in a commercial building flushing several hundred toilets, where we have to have a very reliable source. They're duplex, they're variable speed drives with very sophisticated controls. So once again we're matching the sophistication of the system with what the intended use is. And that last step then would be to manage and monitor the overall system. And we do our own programming controls. This happens to be a red lion control panel, so you can page through here and see how much water's in the tank, how much pressure's on the filters. We're getting the right kind of chlorine there. It's a time to change the UV bulbs. Are both the pumps working correctly? So it's really a lot of diagnostics that are taking place all the time, and reporting that here, or also through a web interface, or through building automation systems. So once again, we're scaling the complexity of the system up to match the sophistication of the building and the use of that building as it's required. Any questions about that, about the system design? I've got a few slides kind of showing you a couple of case studies with the minutes we've got. Sure.
Well, I have a few. As far as what's covered, as far as rainwater harvesting, water reuse, and the Green Code supplement,
Yes.
is that a comprehensive document that you agree with and that you would use or you would advise?
That's a great question, and the answer is we participated in the Green Code supplement writing. So we did review that. We were able to raise, I think you were there too, right?
Well, I was the chairman of that.
Well, you know we were there too.
I know that.
And the answer is yes. I think we're very supportive, and we've been selling that now, and we're talking to communities that are questioning that, and we are actively promoting the Green Code supplement because first of all, we're glad that there's some standard terminology as far as defining what reclaimed versus rainwater versus greywater is, and then the definitions of that. So we're glad that there's a standardized code for that.
I've got another question.
Sure.
And I think your reference to polished water, which you used,
Yes.
should be in the Green Code supplement because that's a new term. And I love that term. And could you explain a little bit what you mean by that? You know, it was almost like a colloquialism that you use.
Right.
But I like the word polished water. Run that past me again.
The term, when you use the word polished, we're really talking about getting the water clean looking, sparkling clean looking. As opposed to, I mean, when you're normal filtration, you've got maybe some sediment that might build up in toilets, for example. There might be some slight discoloration of that water. So polishing is just getting the water looking cleaner, really. And also if you're going to be irrigating, you're going to go to the misters of an irrigation system. You're spraying, then you want the water down to have more and more of that particulates taken out of that water. So.
How would that affect where you get into the jurisdictions that require colorization of water?
It wouldn't make any difference. No, we usually we done a final filtration, then we're adding coloring to that afterward.
Polished water.
You have polished water that's blue, right?
Is the blue is that increasing or decreasing as far as?
It's very regional. So we're seeing that in New York. We're seeing that on the East Coast, Virginia area, I think it is. But there are only a few communities now where that's required to guarantee no cross-contamination. Huh? It's a maintenance problem. It's a maintenance issue. It's probably the biggest reason that it's not being required in more areas. That we're seeing that it's a nice way to guarantee you don't get cross-contamination. That's the only reason you do it.